All right, so this is going to be our first attempt at a video. This is section 3.3, increasing and decreasing functions with the first derivative test. So the plan is to be able to find the derivative function and then also identify the critical points as either maxes or mins or relative maxes or relative mins. So if you look at this graph, right, what we're trying to find is the local max, local min, or extrema, and you'll see that they occur when the derivative is either equal to 0 or undefined. Right, there's several places here where the derivative is equal to 0, which means our tangent line is equal to 0, creating these max or mins. And you'll also see places like this where the derivative would be undefined. It'd be a vertical slope, a vertical tangent, and those places can also have maxes or mins. So if we want to identify a critical point as either a max or a min, we have to see the behavior around the critical point. So we want to determine, is it changing from positive to negative or negative to positive? You'll see here that both with the derivative being equal to 0 and undefined, if it changes from positive to negative, right, so it's going positive to negative, you'll see that it's going to be a local max. And just the opposite, if it goes from decreasing negative to positive, then it has a local minimum at whatever that critical value is. If it does not change sign, right, if it goes positive to positive or negative to negative, then there is no extreme value at that point. So not all critical values have to be local max or mins or extrema, but all extrema have to come from the critical points. If you're looking at endpoints, because we talked in class about how sometimes they'll put restrictions on the domain with these endpoints. If you have a left endpoint, right, if your derivative is going towards the endpoint to the left, that is going to be a max. And if it's coming down to the endpoint, that's going to be a min. And just the opposite, if it's coming down to an endpoint on the right, it's going to be a minimum. Up to an endpoint on the right, it's going to be a maximum. So the first thing we're going to look at here is this example. And this example will start off the same way as most of our other examples. We're going to have to find the derivative first. So let me switch over here and we'll get started. So let's go over to the document camera. And there we are. So if we look at this example, we have f of x equals x to the third minus 12x minus 5. Now, I'm not going to spend a whole lot of time with the derivative because we've been doing derivatives for quite a while. So I think that should be something that most of you are comfortable with. So the derivative of x to the third, we'll have 3x squared. The derivative of negative 12x is negative 12, and the derivative of our constant is 0. So there's our derivative. Now, this function will never be undefined, right? There's no denominator for it to be undefined, so we only have to worry about when the derivative is 0. So if I set this derivative equal to 0 and solve for x, I get 3x squared is 12, x squared is 4, and then don't forget, when you take the square root of a number, we're going to have plus or minus. So the square root of 4, we're going to have plus or minus 2. So that's where we had stopped before, just identifying critical values. Now what we're going to do is we're going to do what's called a first derivative line. So here's my derivative, and I'm going to make this line. And on this line, I'm going to put all of the critical values where the derivative is either 0, undefined, and if I have endpoints, I'll list those endpoints as well. In this one, we were not given any endpoints, so I'm just going to list the critical values. So I'm going to put negative 2 and 2. Now, to determine whether it's a max or a min, I need to determine whether it's increasing or decreasing. So in order to do that, I'm going to plug values from this interval back into the derivative, because the derivative gives me the slope, whether the slope is increasing or decreasing. So if I test points to the left of negative 2, let's pick negative 3, right? And I put negative 3 into the derivative. That's 3 times negative 3 squared minus 12. So 3 times 9 minus 12, 27 minus 12 is 15, right? That actual number doesn't matter so much as the sign. Is it positive or is it negative? If it's positive, it's increasing. I'm going to put a plus in that interval. I'm going to do the same thing. I'm going to find a value between negative 2 and 2 to test. The easiest one to test is 0. So if I put a 0 into my derivative, I get 3 times 0 squared minus 12, which is negative 12, which once again, the actual value, not that important, but the sign of that value is, that's a negative, so it's decreasing there. And then same idea to the right of 2, I'm going to pick a 3. So I'll do 3 times 3 squared minus 12, right? Same as over here, because it's being squared, it's just going to work out to 15. So that's a positive. So as we talked about in the notes there, if you're going from increasing to decreasing, right? Positive slope to negative slope, this value here is going to be a maximum, right? This slope is increasing, this slope is decreasing. It creates that maximum value. Over here, if it's going decreasing, then it changes to increasing, right? Decreasing to increasing gives you a minimum value. So I know there's at least a relative min or relative max at those two values. Now, to find the actual value of the max or min, or relative max or relative min, I would have to plug this value and this value back into the original, right? So let's go down here. If I put negative 2 into the original function, that would be negative 2 to the third, 12 times negative 2 minus 5, right? So negative 2 to the third is negative 8. Negative 12 times negative 2 is positive 24. So I have this, right? And that should give me, I believe, 11, right? Negative 8 plus 24 is 16. 16 minus 5 is 11. So there is a max or a relative max at the point negative 2, 11. If I do the same thing with my other one, put a 2 into the original, and I get 2 to the third, minus 12 times 2, minus 5, I get 8 minus 24 minus 5. So 8 minus 5 is 3. 3 minus 24 is negative 21. So I have a relative min at 2, negative 21. Right? Now, if you look at the graph, I sketch the graph just here on Desmos, just to show you an idea. Right? This is a graph of the original function. So on this original function, you'll see two spots where the tangent line slope would be 0, right? So our derivative would be 0, two critical values, and they occur at negative 2 and 2, which matches up with our derivative line here, negative 2 and 2. And it does appear that this one is a relative max, and it does appear that this one is a relative min, right? At a value of 11 up here and negative 21 down here. Obviously, not drawn to scale. So this just kind of verifies what we were thinking based off of the actual math that we did. Okay, let's try one more. Let's do another function that's maybe a little bit more difficult. So we have x squared minus 4 to the 2/3. So let's look at this one. All right. So for this one, in order to find our derivative, we're going to have to use the chain rule. So if u is the inside, the derivative is 2x. U to the 2/3, the derivative is 2/3 u to the negative 1/3. So my actual derivative here, if I multiply these together, is going to be 4x over my inside x squared minus 4 to the 1/3, just moving this to the bottom to make it positive. So for this one, we will have not only the derivative equal to 0, but it will also be undefined. So the derivative will be equal to 0 when the numerator is 0. So when does 4x equal 0? Well, of course, when x is 0. And then when is it undefined? Well, if x squared minus 4 to the 1/3 equals 0, then that function will be undefined. So if I take the third power to get rid of it and add the 4. I get this, and same as before, square root of 4 plus or minus 2. So now I have this derivative line, no endpoints again, so we have -2, 0, and 2. And we just got to find when is it increasing, when is it decreasing, right? Is the derivative positive or negative between these intervals? So let's test a couple points. Let's test a -3 first. So if I put a -3 into the derivative, I get 4 times -3, -3 squared minus 4 to the 1/3. So that's going to be a -12. -3 squared is 9. 9 minus 4 is 5. So the cube root of 5. So this is going to be a positive number, a negative number, which means I'll get a negative number out, right? Like I said, I don't really care about the actual value. I do care about the sign. If I put a 0 in, sorry, a -1 in, I have to go between -2 and 0. So I put a -1 in, I get 4 times -1. -1 squared minus 4 to the 1/3. So that's -4. -1 squared is 1. 1 minus 4 is -3. -3 to the 1/3 is a negative number. Negative divided by negative is positive. Same idea. If I put a positive 1 in between 0 and 2 here, I'm going to get 4 times 1 over 1 squared minus 4 to the 1/3. So positive 4 divided by -3 to the 1/3. So that will be a negative number, positive divided by a negative. And then for the last one, if I put 3 into the derivative, I'll get a positive 12 over a positive 5 to the 1/3, which will give me a positive number. So if I go from decreasing to increasing, right, decreasing to increasing, that looks like a minimum. Increasing to decreasing, that looks like a max. And then decreasing to increasing, another min, right? It is possible to have multiple relative mins or multiple relative maxes, but only one absolute max or one absolute min. So from there, we would put the -2, 0, and 2 into the original function, find the actual coordinates of those maxes and mins, and then we would be done. All right, so I hope this video helps you. This is critical values using the first derivative test. I'll put some more examples in Classroom for you, and you can go from there. So good luck, keep practicing your math, and we'll see another video shortly.